Hello, good evening, ladies and gentlemen. So welcome to the seminar of the Knowledge Exchange Program for Enhancing Urban Horticulture Industry on Expecting the Technology and Sustainability Mindset series. This seminar workshop is organized by DI, Technological and Higher Education Institute of Hong Kong, and our collaborating organization is Hong Kong Greening Contractor Association and the Hong Kong Institute of Horticultural Sciences. Today, this is our second seminar for the native ornamental plant utilization in urban landscape. And I would like to also briefly introduce our seminar series to you. Our seminar series is called the Expediting the Technology and Sustainability Mindset series. And we would like to enhance the horticultural technological exchange and to facilitate the overseas and local professional to exchange your horticultural technology and advocate the current urban horticultural practices with sustainable measures, and also to explore the Hong Kong urban horticultural market in terms of international level. And for this seminar workshop series 2, we will split into 2 days. Tonight we will have 3 speakers, overseas speaker tonight. So we have quite a very rich content, and then covering today's topic of native ornamental plant utilization in our urban landscape. So in fact, this topic is quite hot among the horticultural industry and also among the landscape management industry. So in fact, we are also hearing the application of utilizing more native plants in the urban areas. But many practitioners may have the doubt whether the native plants would be able to adapt to the urban environment. And there are a lot of considerations for the before bringing those native plants to our quite rigid urban landscape, because there's quite harsh environment and also all this polluted air and also a very hot and harsh environment. So we might have a lot of consideration before bringing in all this native plants, and also from the point of view from the ecological benefit, we always have a lot of benefit from during bringing more native plants by enhancing the urban biodiversity. Okay, so without further ado, today I will first introduce our first speaker, Professor Richard HAUER. He is quite a friend of DI, because we have a lot of connection with Professor HAUER, and he has been visiting Hong Kong for several times to deliver the speech related to urban horticulture and urban forestry. Professor HAUER is a very well-known author, and also in a lot of textbooks, and also in a lot of general articles, we will see his name there. And he is now a professor in the urban forestry at the University of Wisconsin, Stevens Point, and teaching the course of urban forestry. And he obtained a PhD from the University of Minnesota, and he conducted a lot of research in tree biology, urban forestry management, and also the emirate of ash borer management, and tree and construction and tree risk management and ice storm. And he was honored as a Chadwick award for horticultural research, and he has a very impressive amount of publication, 130 publication, and presented over 300 talks throughout the world. And today he would present a topic on what happens when we take the native tree out of the forest. And then he will talk about this, what do we need to consider if we want to choose suitable native tree, and he will present a step 1, 2, 3 to us. Okay, and I will, without further ado, I will now invite Professor HAUER to give us his speech. Okay, so maybe I will invite Professor HAUER to share your PPT.
Can you see it, Caroline?
Yes.
Excellent. All right, well, thank you so much, Caroline, for that beautiful and wonderful introduction. I appreciate that very much. So this morning, first of all, I kind of can feel the love in the room here, even though we're virtually apart. I feel a connection to everyone that's online this morning. For me, for you, it's in the evening. But when we take the tree out of the forest, this is actually a picture of a forest that hopefully someday you get a chance to visit. It's in the central United States. It's in the state of Missouri, but it's an Ozark forest that has oak trees, quercus. And now these trees, one of the things they really have to deal with is in the summertime, it gets very hot. And so hot, and it can also get very dry, where periods of moisture limitations can be great. Now, if we also think about the forest, we could look at many inputs and many things that actually are going on within the soil environment. Now, we're not going to get into this depth at all today. We could actually just talk about something like the nitrogen cycle itself and look at all the organisms that are involved with actually just maybe the denitrification of nitrogen and the release back to the atmosphere. We could look at actually the input of leaf material. So the point here is actually, if you think about the forest, there's a lot of just phenomenal, interesting processes going on that we could tackle just in a seminar alone. Now, we could also sometimes bring the city to the forest. Now, this is not an uncommon thing because people love trees. And that's certainly why we're all together here, is not only because we love trees, but also how can we actually best bring trees to the city, or if we bring the city to the trees. Sometimes we certainly do bring the tree to the city. This is Canberra, Australia. Now, if you know anything about the history of Canberra, it's a very dry environment. And they actually spent a wealth of just phenomenal interesting research 100 years ago to kind of quantify and figure out how do you actually best bring trees into an area that doesn't want to have trees. So that's a lesson you can learn from. Or you could have areas where it becomes quite challenging, okay? A little overlooking the harbor here in Hong Kong. But yeah, it can be quite challenging when we bring large components of the city and then we try to have these green. So perhaps you've read this book before. There's actually a Cantonese version of this. It's The Little Prince. But there's a line in this book that I think really resonates with what we're going to be talking about today. And if you think about it, you become responsible forever what you have tamed. And in a sense, this is what we're doing. If we bring trees to the urban environment, we're trying to tame them. But sometimes it can be humbling. If you think about trees, can you actually tame a Chinese banyan tree? You know, with the aerial roots that come down, sometimes they almost tame you. And these are pictures from throughout the world. They're not my pictures. I'm giving credit to the author of who took these. But perhaps you've seen some of these. Or a little bit closer to home in Hong Kong. Perhaps you've seen this taming of a hold home with the Chinese banyan tree. Certainly the wall trees of China, of Hong Kong, who could not actually not only love these, but also think of the challenge it is to actually maintain and manage these over time. And I've seen these, and I know some of the challenges you have with these historic features of your city. They're beautiful. And we could actually look at a cousin of the Chinese banyan, the Moreton Bay fig. Now, this is a very popular tree throughout the parts of the world. And not that this tree has aerial roots, but it has buttress roots. And so taming this tree can be quite a challenge in our urban environments. So these will be lessons that we're going to be talking about. Now, this is the roadmap where we're going. We're not going to tackle all 8 of these. And actually, I'm going to get up to water. I'm going to tackle the first 4. These will be part of my ingredients of tree success. And the last four, especially maybe essential elements, that in itself could be tackled as a seminar. Just what are the essential elements? What are actually the best way to get nutrients to trees, and how much do they actually need? And then how can we quantify if there's a deficiency? All right, so let's talk about energy first. Now, perhaps you remember many years ago as a child, maybe you're in what we would consider here in the United States 4th grade. This is the 5th time that you go to kindergarten, then 1st, 2nd, 3rd, and 4th. You get kind of introduced to starch, and you may look at a root crop. In our country, we'd look at the potato. But I'd suspect in Hong Kong, you have other trees, or you have other plants that that will stain through starch a deep purple. And this gives you kind of an indication of how much energy is in the root system. Now, this is an interesting idea that no one's really tapped on. How do we actually quantify the health of a tree based on its energy reserves? We can do this scientifically. We can actually quantify how much carbohydrates are in the root system. It's not an easy test from time. It's not a difficult test. This is done all the time in the laboratory. But we could take some cues from nature, though. Just like all of us, for me, I got up about an hour and a half ago. For you, you're getting ready to go to bed. You rest. Every organism rests daily, but they also rest seasonally. Sometimes we actually go on a vacation, and trees do the same thing. Now, in my part of the world, we get winter, we get snow. We actually have trees that in the fall of the year lose their leaves. Now in Hong Kong, you have trees that are deciduous that you can certainly see during the growing season where they're going to shed their foliage and then they're going to be leafless for a period. But you have many evergreen trees that hold their foliage regardless. They go through a period of rest, and actually when they reawaken in the springtime for us, they reawaken and they have this burst of new foliage, and that takes a lot of energy. And so this is a graph that actually a Russian fruit scientist, Askenasy, came up with. And it's quite fascinating. That says it takes a lot of energy to get trees started. And then they actually, if all goes well, they accumulate all that energy and they stay as a healthy tree. But there is a weakness in that period of time, actually, when they're putting on the foliage. Now, if we think about trees also, we can look at trees, and actually most trees just don't wake up and get killed by a biotic organism. Actually, what happens before the biotics come in, like an insect or a fungi, they get set up for failure. So drought, air pollution, as Caroline mentioned earlier. Where I live, actually salts. We actually put salts down in the wintertime to melt snow and to actually prevent snow and ice from accumulating and making a safe surface for people to walk and also to drive an automobile. But also when you put the salt down, it actually causes a drought-like environment for trees. So we have to actually select trees to actually tolerate with these various abiotics, so a secondary pest like insects or diseases doesn't kill them. Now let's look at genetics. We'll just talk about this very briefly for about a couple minutes. But all trees are based on their heritage. Now this is an American beech tree. There's a European beech tree, Fagus. There's Fagus trees actually from Asia, but they have a genetic tendency for height, for canopy spread, how big they ultimately can get. And so there's the genetic cues, regardless where a tree is growing, that we have to actually think about and tap into. Now, this is an area in itself that we could have an entire seminar of the genetics of trees for the urban environment. And unfortunately, there's not a lot of research that's being done in this area. More so when we select plants, we select them for fruit and foliage and maybe color of leaves. But thinking of tolerance for urban environments, this is a huge potential to tap into that a lot of research was done a few decades ago, but less is done today. But we can also take our cues from things like the Köppen climate classification system, which really is all about heat and temperature and water. And so, we could journey over to where we are if we're all together here, rather than virtually. As you look at Hong Kong, for example, and see what do you actually have for requirements for growing plants based on the Köppen climatic classification system. Now let's journey down to Australia and think about what they have actually done. And if you're not familiar with this work, if you're an urban planner, if you're an urban forest manager, if you're a manager of actually landscapes for private companies, this is very important to think about. Is what do you currently have for vegetation, And what's the environment going to be like 20 years from now, maybe 30 years? So planning ahead into the future. Now I get it. I used to be a practitioner, and we think about what is the plant going to look like after we leave the job site? And what's the street going to look like after you plant a tree? And thinking about 30 years down the road is a little more challenging. But in Melbourne, Australia, what they did was they looked at all their trees, they mapped them, and they gave a useful life expectancy. Basically what it means is these trees in red, they believe are not going to be around as healthy trees within the next 10 years. And one of the reasons is certainly Melbourne was heavily influenced by Northeast or Northwest Europe, where actually the plant materials of Northwest Europe, for example, England, had a huge, obviously, connection not only to Hong Kong, but Australia, is the plant materials that are actually being used are a reflection of people 100 years ago. And so many of these trees that are actually in red are on this list that are actually trees that are very suitable for cooler climates, but as temperatures get hotter and drier, they're the trees that are the red trees that they have to think about replacing with plants that are actually more resilient to hotter and drier temperatures. Space to grow. This is very, very important. We're going to actually spend the next about 15 minutes or so talking about space to grow, quite vital. Now, trees need space. They need space for root systems. They need space for tree canopy. And if we think about space, sometimes trees are amazing. They can get by with very little space. Now, this is a tree, loblolly pine, from southeast United States, the state of Atlanta. This is the state just north of Florida, to give you some reference. But these are drill holes that were actually drilled in so they could actually blow up this rock for just building materials. Fortunately, they stopped blowing up this beautiful mountain on near Atlanta, Georgia. But in the process, these little drill holes are really, if you think about it, sometimes small, confined locations we try to force our trees in the urban environment into. Yes, you can grow trees in these small soil environments, but they don't get big. Now, what if we want to actually get big trees? Now, if I was in person with you, I'd ask the question, I'd pause for a minute, and I'd say, how old do you think these trees are, and what size are they in diameter? Now, in English units, they're 2 feet, okay? And the metrics in meters, they'd be approximately about 0.8 meters, 0.7 meters in diameter. But they're 50-year-old trees. They're quite large. How did they get to be that big? Well, actually, interesting enough, there's a forestry professor at North Carolina State University that knew something about trees and soil volume. And if you look at this graph here, this is where the tree would be planted. This is actually the width, and this is the other dimension, okay? Soils are about maybe 2 feet deep, and so that would be approximately about 0.7 meters in depth. And if you look here, from here to here, 5.5, or all the way across, from here to here, 5.5 meters, another 5.5. If you add all this together, okay, you get an area that's large enough to grow a tree that's about 40 centimeters in diameter. Okay, that's 50 years of age. And this is actually just not someone's academic exercise. This is actually reality. This graph is based on data from throughout the world. So the lesson here is if you want to get trees to get bigger and bigger and bigger, it's all about soil volume. Now, some of you actually may be into the process of keeping trees very small, bonsai. Okay, so how do you keep trees very, very small? You give them very little soil environment. We have known this for many, many hundreds and hundreds and perhaps thousands of years. And if you're curious how old this tree is, maybe you'll be really excited to learn. This was planted in 1737. This is an old tree in a very small soil volume. But if you work with bonsai trees, you know very much that it's a love, first of all, for the plant. It's an art of forming the plant, but it's also science of the below ground resources that you're very often doing something to the tree root system, replacing soil where you're adding more nutrients. So you can, but you don't get trees large in a small soil volume. Now, this is a situation of my home state, the state of Minnesota. And this is if you look in the central part of the United States and go all the way up towards Canada, that's the state I grew up in. So this is an area where it was a rest station. So an automobile comes in with people and they take a break. There's restrooms here, facilities, you could have a picnic. But here are trees in a small soil volume versus a large soil volume. The trees were planted in 1988. Okay, I took the pictures here in 1998. They look pretty similar. And actually a few years later, I came back 2016 and took pictures again. What do you notice? Well, here's the ground line, here's the canopy. Here's the canopy for the trees in smaller soil volume. Which ones are bigger? And so the lessons here, if you're thinking 30 years, 40 years down the road, is what you do today has a huge influence on what you have for people in the future. And this is certainly all due to soil volume. Actually, if you looked at some other pictures that I have and you looked at the bark, these trees are actually dying back already. Insects are coming in and actually colonizing these trees because they're weak, because of less soil volume, more drought-like conditions. Now, it can be quite challenging when we want to have roads and we want to have sidewalks and we want to have utility lines, places for people to actually be, places for people to live, places of business. It gets quite challenging. To then add the next element of the green space and planning. Planning ahead before we do this is very vital. Retrofitting after the fact can be quite a challenge and be quite expensive. So if you think about, sometimes maybe the best option is small trees. And this is actually, if you visited me someday, this is the building I'm in today. This is our College of Natural Resources. But these trees were planted 50 years ago. This particular tree, this is about the mature height. And so for the soil volume that was available, we selected, or I should say my predecessor selected, a tree that's very suitable for soil volume. So that's one option. The other option is we find ways to become quite creative. And I think this one is it just fascinates me. This is in Canberra, Australia, where they took this rubberized material that you'll see sometimes on an athletic track where people could run on this. Sometimes you see this in children's playgrounds where we have, swings and things that kids could play on. And if they fall, they hit this rubberized material. And so in the process is you have all this soil volume underneath this London plane tree, and you have a surface that people can walk. This is permeable. And so this gives a situation where trees can become quite large and have a space to grow. Now, sometimes in very limiting environments, the only place you could have a tree is maybe actually in the street. Now, we use an English term, a street tree, and typically when we think of a street tree, it's not a tree growing in the street, it's a tree near the street, okay? Now, in this case, the only option of having trees here were in the street. And this actually fascinated me when I saw this. This was only about 8 years ago. Now, I've been at this business now for, I'm in my third decade of actually thinking about trees and urban forestry and arboriculture. And so it was 8 years ago when I saw, actually it was 6, where I saw these trees in the street, and it made me kind of think, how are these trees actually healthy? Now, I don't know much about the soil volume underneath, but I do know that actually, if you actually plan for soil volume, and we could actually have an entire seminar on that, we can get large trees, we can have trees maybe in streets, and we have ways actually to have structural systems in place where automobiles can be, people can walk, and you still have soil volume. So places for cars to park and to have vegetation and being creative. Now, these are just pavers on top of some sort of base material, but automobiles are here and you have trees. Now, sometimes you have issues with automobiles hitting tree trunk, and that causes damage in itself. And probably the person that hits the tree gets more mad that the tree's in the way. So one solution is put bumper guards. Okay, but my point here is not necessarily forcing trees into a street. Sometimes that's the only option. Now, this is an old system. This is a very common system in many places throughout the world. This happens to actually be a picture from Milwaukee, Wisconsin, and that's a city just north of Chicago, Illinois, that you may have some reference to. But here is a large tree in a confined location. And now one issue we have here is sidewalks lifting. And then the damage, and I'll talk about trees and construction here in a little bit, is actually how do you actually easily maintain sidewalks and trees? It becomes quite a challenge. So you can either be challenged or you come up with a solution. And really, the mature tree size, we do know that if you're maybe 1 to 2 meters away from these concrete surfaces, that's all you need for most trees. Now, I'm not talking about ficus. I'm not talking about the Chinese banyan tree, nor am I talking about the Moreton Bay fig that I showed you earlier. I mean, those root systems basically would devour a sidewalk potentially in the street in itself. But I'm talking about many trees, things like maybe you have a London plane tree in Hong Kong. that you've seen, that these trees of the root system, by the time you're about 2 meters away from the tree trunk at maturity, you actually are not going to cause infrastructure lifting. So if you think about minimum locations of size, is if you think about mature tree stem and you add on 3 to 4 meters to that. This is a width that you need to actually have for suitable growing. And now this is soil. You could put rubberized material around here. Now, not all places need this, but in places where you have confined locations and you want to have places to walk, places to park, and to have buildings, this is one solution. Trees also like buddies, okay? I'm really big into trees need a buddy, just like us growing up as children, having a friend, and we'd use the term buddy in my country, a friend, a buddy. And trees in the forest grow with friends. They grow with buddies, and actually close spacing. And we actually tend to recommend planting trees today further apart. So this one and this one will not be planted perhaps, but this would be planted to get wide canopies. But in the forest itself, these are naturally forest, they prune themselves naturally. This is an area that I think would be fascinating to actually research, and I'm starting to dabble into this about trees need a buddy and spacing, and actually what's the effects on the tree canopy in itself, and economics and things like that. But trees need a buddy. And if you think in a forest environment, the forest effects of having a buddy has a huge effects on what their architecture is going to be. Now, these trees actually do have a genetic capacity to have wider crowns, but when they're with friends, they have a more narrow crown, more or less likely to get toppled over by a windstorm, and they work together functioning as a whole organism in a sense. But if we take that same forest-grown tree and we put it by itself, we get wider canopies. Now, these can be attractive, quite gorgeous. And I'm not saying don't have open grown canopies, but what I'm saying is thinking about the forest, the genetics of what it's going to be if it's forest grown or open grown. And now if you have a tree and it's open grown, there's some things we can do as managers. If we do nothing, this tree, which is actually a juglans, it's our the pecan tree. And this tree in itself, and we have another tree, black walnut, Juglans nigra, from our country, and there's Juglans certainly from Asia. And I've seen many Juglans respond the same way here. That if you do nothing, you'll get multiple leaders, and over time they become like this. And they become perhaps, and right here, this branch is poorly attached to this tree stem, bark inclusion. And one solution we could have at a young age, we prune off this branch. Okay, so snip at a very young age, just as much as I don't imagine we have any children that have participated today, but we're all children at one time. And some of us actually have children. And when children have bad habits, we correct them. Trees, the same thing. Correcting a bad habit, this branching habit, so it doesn't become this, at a young age, it's one of the least expensive things we can do. If we don't, though, we can get multiple leaders, bark inclusion, and then maybe 30 or 40 years down the road, a big limb falls off because of what we didn't do 30 or 40 years ago. Now, this is Celtis occidentalis. It's the American hackberry. You have trees in Hong Kong that do the same thing, okay? And so you may have never seen a Celtis occidentalis in your life. You maybe have seen Celtis chinensis or sinensis, okay? The Chinese hackberry does the same thing as our hackberry from the United States. Is over time, I call them boom boom trees, because when you get this large limb, and this is all decay up here, by the way, these branches are actually swaying in the wind, they're rubbing and they're causing wounding. And so this tree failed from decay, but it failed from decay because many, many years ago, this action did not occur. Now, if you look at the economics of this, one study from actually Melbourne, Australia, that they found that if you, what we call formative pruning, so at a young age, we prune off limbs so they do not become like this. It was about 16 times less costly to train trees at a young age than to do nothing, okay? Now let's talk about trees and construction, because this is an important thing to talk about. We do know one thing, that with many, many trees, if you multiply the diameter by 5x and you stay away from that area where you do not damage this root system, their likelihood to topple over after construction is done near them is very minimal. Also, you're not damaging these trees roots within this 5X, you're also maintaining actually not only the structural, but the biological potential. Now, if you do need to do some sort of activity within this area, we need to use tools where we can actually safely remove the soil so you can see the root system so you don't damage it. And actually, from one study that was done, they found you could get a little bit closer. We have a North American standard, though, that says 5X. You do not get within 5X of damaging, severing the root system. If you have to, and there's cases you have to, other precautions may have to be taken in, where actually tree removal might be the only option. Now, this is a tree stem. We're looking straight down as what we'd call a bird's eye view. So we're looking straight down at the canopy. Here's the tree stem center. This is that 5X, what we could call also the critical root zone. Now, this is from the International Society of Arboriculture. This is a standard that they have. And we also have another thing called the critical root zone. And so if you multiply it, depends on the species, this diameter by 6 to 18x. Trees that are really sensitive to construction, you want to stay 18x away and not damage within the root system. But trees have some redundancies built in. So even within this critical root zone, maybe we have to do some excavation, okay, and remove the root system for maybe putting in a building footprint. Now, you can get away with this. It's best if you don't, but trees do have some tolerance, so you want to do no damage over here. So here's an example that putting in park benches or putting in bleachers so you could watch children play soccer is here's the tree multiplied by 5. Here's that absolute root area. Multiplied, in this case, this particular tree was a hackberry, and you get within about 12x on this particular species. Now, I don't know of any good lists for Hong Kong or Southeast Asia. There are some really good lists on trees and their tolerance to construction in North America. Maybe they are lists that have been developed for Hong Kong. If not, that's a research area one of you perhaps could undertake. But if you look at this, they had to actually excavate for these bleachers. They were able to do it. Okay. Now, how do you actually communicate with contractors and communicate with engineers? They speak in a different language. They speak in computers. They speak in CAD, computer-aided design. So if you have the tree stem and you have the diameter and you spatially locate this, you could put this nice circle on a CAD drawing. You could put the critical root zone, and this is a footprint for where the sidewalk is going. So now you can communicate with the engineer of here's tree, here's where you can do nothing. Here's where you have some ability to do some work, like this third area. Sidewalk could be put in and tree could be retained. And actually, this is just not an academic exercise. This is actually a true life situation from New York City. My friend Jeremy Barrick, he was the engineer of urban forestry on this project. And these trees are still there today. I've actually seen these. And so pre-planning ahead of time, if you want to have actually trees retained after construction, it's all about biology. What's the tree diameter and how far away do you have to stay? And what kind of tolerance do trees have to some sort of activity? Now let's talk about the last thing, water. And I'll have about 5 minutes for questions here. And I'll be around for the other speakers. So after the other speakers, if you have any final questions, I'd be happy to answer those. Trees need a lot of water. They need about 500 grams of water for 1 gram of developing tissue. If you think about that, that's a lot of water to produce, 1 gram of leaf material. You need 500 grams of water approximately. Now, this is one of our just splendid trees in the world, the giant coastal redwoods of the western United States, for example, California. Hopefully you've had a chance to see these. If not, you could, San Francisco, just north of San Francisco, you could actually visit some beautiful forests. But my point here is within 2 meters to the ground or 35 meters, all the way up in this particular tree, 112 meters from the ground, what do you notice? Leaf tissue gets smaller and smaller and smaller, and trees adapt. Trees adapt to water deficiencies by reducing their leaf mass. And trees ultimately have a limitation to how much height they have by pulling water up the tree as it leaves the leaf through transpiration. Now, I'm suspecting many of you already know this process, but the bottom line here is this pulling force, it's a much drier environment up here. Trees are under a lot more water stress at the upper canopy than they are close to the ground. Now, trees have a lot of challenges, and certainly as a global community, we have a lot of challenges potentially facing us from what's the climate going to be like 30 years down the road. I talked about Melbourne as one example that, they're planning for the future based on what they believe are going to be climatic conditions 30 years from now. And if you've been following, climatic news of Melbourne, Australia, they've had, or just that part of Australia, they've had some just wicked, wicked dry. Last year was such a huge fire year, and because of dry and heat, and so perhaps you've kept up with, what they're facing, and that's kind of a predictor of things that other places in the world may face. Now, when we design things, and if we think about the future, having drier and less rainfall at times is something that we have to plan for. Now, creating environments, we can create environments that already create this drought-like condition where we give small areas for trees and very little ability for water to get here, okay? By the way, this is going to be the mature size for this tree based on soil volume. It's just biology, whether a person likes it or not. The soil volume is very, very important for big tree canopies, but also the ability to actually get water here. And this is just wickedly small area for planting trees. And I imagine every one of us here this morning, for me, evening for you, has actually seen trees in these very small areas, okay? They don't get potentially as big as they could get, and they're dealing with drought-like conditions. And they also will tell you, they may have foliage that looks scorched. Now in Hong Kong, you get more rainfall than I do in Wisconsin, where I currently live. That's a state just north of the state of Illinois, where Chicago is. So these environments, trees will respond by reducing their leaf mass by actually having it die to reduce the amount of leaf area for the ability to actually bring up water to facilitate photosynthesis, for example. We can create environments where we actually don't allow water to get there very easily. So raised planters, they can be wonderful, but then we have to actually bring rainfall in naturally, or artificially through irrigation systems. So rather than doing that, we could actually design systems. And actually, if you journey up to Sweden, they've done some of the most interesting work of actually creating environments where water infiltrates and that water passively actually irrigates. And so you have to think about not having too much water flooding out plants. But the engineering, they've got it down pretty well of how to actually get water into an area where roots are going to be. So you're storing water on site rather than keeping water from the plant, okay? Now, trees are much like us. We're in the morning, we wake up, and this is me right now. I'm just very invigorated. I'm like this foliage on this betula tree. I'm very well hydrated, and I had pretty decent sleep last night. I had about 4 hours, so that seems to be normal for me lately. But by about 4 hours from now, I'm going to look like this. And maybe some of you right now are listening to me and you're wilting. Okay, you're getting tired and you're ready for sleep. Maybe that's just naturally and it's not me. But plants are like us. They go through midday siestas, especially if it's dry, where they'll curl up their leaves to reduce the leaf area that's being potentially hit upon by sunlight. This is just natural. Okay, trees do this. Trees also have mechanisms like the Joshua tree, which isn't a true tree itself, but it certainly looks like it. I hope you get a chance to see these someday in your life. Or olive trees from the Mediterranean area where they have a smaller leaf area, shinier surfaces. So thinking again about genetics and picking plants that actually are suitable for the site that you actually have. Now, if you don't water trees, this is something we do know, is trees naturally, their ultimate canopy size is a function of water. And so if trees are under water stress after transplanting, the terminal leader will stop growing or grow at a much reduced rate, and these lateral branches actually will grow proportionally faster than this main lead. So just by transplanting and not watering trees, we can create trees to have these multiple leaders. Okay, this is just natural. This just isn't a North American thing or a Europe thing or an Asian thing or an Australia thing. This is a biology thing for plants. And so now after transplanting, you can actually, for you, if you had a 5 centimeter tree, it may take 1 to 2 growing seasons to fully actually recover from the pre-transplanting growth rate. You transplant, you sever root systems. In this case, it took 2 years for this tree to actually recover. It was a 5 centimeter in diameter tree stem. And by the 3rd growing season, actually it's growing again like it was prior to harvesting from a nursery because it's reacclimated its root system. If you don't water after transplanting, the biotics come in. And we have a condition of trees they used to call sun scald. It happens on the southwest side of a tree. And it's actually not the sun that's the major factor. It's actually water desiccation. So a tree is actually under a poorly hydrated situation. This tissue on the southwest side of the tree dries out more because it's later in the day, it's hotter, more sunlight, and it just becomes susceptible to actually an insect colonizing and using this, what they naturally do as a host for that insect. Now, there's some great watering prescriptions. Now, I don't want you to memorize all this. If you're able to, fantastic. The point here is you can maintain trees for death by no watering. You can maintain for vigor by a greater frequency of watering, or survival, where actually you water not as much, but you water enough for survival. So the thing is, the larger the tree, the greater time it takes for daily watering, okay, for vigor, and less water, but you still have to water on a regular basis to actually get the plant established. Okay, this is from Dr. Ed Gilman. Ed retired about 2 years ago, but his work didn't retire. His work carries on. The key thing here is you can maintain for death. Okay, and so you could think of the black screen that I'm seeing for me right now, or survival, or actually the best practices for just the best healthy tree that you could think of by more water. There's a lot of ways to do it. You can actually, I was one of those persons way earlier in my career where I watered trees by hand. We have water bags. These are Gator bags, but there's many brands out there where you actually fill them up and they water the tree, but you have to keep watering these and filling them up. And you have to also, you just can't walk away and forget about it. So getting us back to the questions that I'm going to have here in the next minute is think about it. I started off earlier that whatever you tame, you become responsible forever for what you have tamed. And maybe you've not read this book, The Little Prince. If you have children, this little book, it's a neat little book. It's the story about a prince who tames a fox. Okay, and maybe you've read this book and you already know the premise. But this prince tames the fox, and so if you tame a fox or you tame a tree, you become responsible forever for what you have tamed. So I thank you so much. Little picture back in Hong Kong. I love your city. I love everyone that I've met there. And hopefully in the near future, I can see you in person. But not, I'm going to stop and answer some questions. So thank you very much.
Thank you, Professor HAUER. So it's a very informative presentation telling us what is all those consideration when we want to bring a native trees to be planted in the urban areas. And okay, I have seen some Q&A on the live chat box, and there is one question from Jessica Park. She asked that one should not import foreign trees, that means they're exotic trees, into one's environment, maybe the local environment, but to use the native trees. Comment please, and are there any exception? That means what is your thought on using exotic trees in the urban landscape?
Yeah, excellent question. We could have an entire seminar just on the implications of exotics and non-natives. One is certainly, is it going to become invasive? And so there are some plants that are bad actors, where they're new environment and they don't have natural pests to keep them in line. But there are many plants also that are good actors that do not become invasive. But there's also other implications. Some non-native plants actually, just the natural fauna, birds, for example, are tuned into native plants, where the non-native plant maybe is a biological desert for native insects, native fauna or flora, or fauna actually in the tree. So that's another consideration. But you also think about in our urbanized environments, That's a kind of an unnatural situation in some regards, but it's also like a mountain where we can create, dry xeric environments. So it's more than not planting native or planting native only. Okay, it's more of perhaps invasiveness and what sort of objectives for maybe birds you have, or maybe other things such as what plants actually tolerate the harsh conditions. So it's I can't just say yes or no to native or non-native, but certainly native plants, if you think about just the fauna in itself, there's some great evidence that native plants are good from that perspective. So thank you, Jessica, for that wonderful question.
Okay, another question. He asked that is anonymous participant, Professor Richard, will the absolute CREZ vary greatly with different tree species? CREZ, but
the critical root zone, perhaps.
Critical root zone.
Yeah, actually, it depends on species, if that was the heart of the question. And there are some trees that are very tolerant for construction, so you can get maybe 6x. So if it's 30 centimeters in diameter, if you're 180 centimeters away from the tree stem, you could do construction outside that area, and you may damage root system, but they can tolerate it. Ulmus, for example, ulmus tend to be pretty resilient to construction, but fagus, beech trees, tend not to be. They have root systems that are very shallow. So if you think about where the root system is, that's another huge implication. And so I just gave you an example with two different plant species. I wish I could let you know about some lists in Hong Kong. I actually don't, of great lists of tree tolerances. And maybe there are. If not, that's something that I would challenge you actually to develop. Great question.
Okay, maybe the last one from Richard Cho. He asked you, can you recommend some species of some stature trees for Hong Kong urban areas? But I'm not so sure whether you will be familiar with the flora or the species here.
Well, actually, I have an excellent answer. This is what our next speaker is going to talk about. Our next speaker, I'm intrigued actually to listen, because this is the expert on native floras for your part of the world. So with that, I think that's the best introduction we could have, is turn over to our colleague.
Yeah.
So thank you, Caroline.
Maybe we just leave this answer to be answered by Professor Tame.
Okay, over the next 40 minutes.
Thank you very much,
Professor
HAUER, for giving us such a wonderful presentation. And I know Professor HAUER is get up very early in the US, and then it was 6 a.m. in the morning, and then come back to his office to give us such a wonderful speech. I would like to send our gratitude to Professor HAUER again on behalf of the I and Hong Kong, also to our audience. Thank you very much.
Thank you.
Okay, thank you.